You probably ate it today. Maybe in your tea. Maybe in your breakfast. Maybe hidden inside something you thought was healthy. And the frightening part? You felt completely normal afterward. No pain. No warning. No signal telling you damage had begun. But inside your brain, a different story may be unfolding. Because one of the most common ingredients in modern diets does not just affect weight, energy, or diabetes risk. It directly affects how clearly you think, how well you remember, and how fast your brain ages. That ingredient is sugar. Not just candy or desserts. Hidden sugars in bread, sauces, cereals, flavored yogurt, energy drinks, and even healthy snacks expose the brain to repeated glucose spikes throughout the day. The brain depends heavily on glucose for fuel. But it requires stable fuel, not sudden surges. When sugar enters the bloodstream rapidly, the body releases insulin to move glucose into cells. This is normal in small amounts. However, when spikes happen frequently, the system begins to struggle. Over time, cells respond less effectively to insulin signals. This condition is known as insulin resistance. Most people associate insulin resistance with diabetes or weight gain. What many do not realize is that the brain is one of the organs most affected. Brain cells require insulin signaling to regulate energy use and communication. When resistance develops, neurons receive inconsistent fuel supply. The brain becomes surrounded by energy yet unable to use it efficiently. Some researchers describe advanced memory decline as resembling type 3 diabetes, because of this strong connection between impaired glucose metabolism and cognitive deterioration. One of the first regions affected is the hippocampus, the structure responsible for forming and organizing memories. The hippocampus is highly sensitive to metabolic stress. Repeated glucose spikes trigger inflammation, and inflammation damages neurons. Damaged neurons communicate less efficiently. The result appears gradually: increased forgetfulness, reduced concentration, and mental fatigue. This process is subtle. You may misplace items more often or struggle to recall names quickly. These changes often appear years before serious cognitive decline. Because they develop slowly, they are frequently dismissed as normal aging. Sugar also contributes to oxidative stress. High glucose levels lead to the formation of harmful molecules called free radicals. These molecules damage proteins and cell membranes within neural tissue. Over time, protective structures weaken. Signals still travel, but less efficiently. The brain must work harder for the same mental tasks, leading to earlier fatigue during thinking. Blood vessels supplying the brain are also vulnerable. The brain relies on a dense network of tiny vessels delivering oxygen and nutrient. Chronic high sugar intake stiffens and narrows these vessels. Reduced circulation means less oxygen reaching neurons. Less oxygen leads to slower processing speed. Many people describe this as brain fog without realizing its metabolic origin. Daily eating patterns often reinforce the cycle. A sugary breakfast produces rapid energy followed by a crash. The brain reacts strongly to fluctuating glucose levels. Attention declines. Cravings increase. Another sugary snack or caffeine temporarily restores alertness, followed by another drop. This repeated instability places constant stress on neural systems. Neurotransmitters are affected as well. Sugar intake triggers dopamine release, the chemical associated with motivation and reward. Repeated large dopamine spikes reduce receptor sensitivity. Over time, normal activities feel less satisfying. Concentration becomes harder. Tasks require more effort. This change is biochemical, not a matter of willpower. Sleep quality also suffers. Late-day sugar consumption interferes with deep sleep cycles. Without sufficient deep sleep, the brain cannot clear metabolic waste effectively. Waste accumulation increases inflammation, which further worsens insulin resistance. Poor sleep and unstable blood sugar reinforce each other, accelerating decline. The concerning aspect of sugar-related brain damage is its timeline. Effects accumulate silently over years. A person may feel mentally sharp at 30, slightly slower at 40, and noticeably forgetful at 50, without realizing the process began decades earlier. Fortunately, the brain has remarkable resilience. Stabilizing blood sugar often improves mental clarity within weeks. Inflammation decreases, and neurons regain efficient energy use. Many individuals report better focus and more consistent energy after reducing frequent sugar spikes. Practical changes can protect brain health. Limiting sugary beverages is one of the most effective steps because liquids enter the bloodstream rapidly. Reducing constant snacking allows metabolic recovery period. Pairing carbohydrates with protein and healthy fats slows absorption and prevents sharp spikes. Choosing whole foods rich in fiber stabilizes glucose delivery. Light physical activity after meals helps muscles absorb glucose, reducing metabolic burden on the brain. This approach is not about eliminating enjoyment entirely, but about reducing chronic overload. The brain is designed for steady fuel availability. Modern diets often provide repeated surges instead. Consider two long-term patterns. One individual consumes frequent refined sugars daily for decades. Another stabilizes intake gradually and prioritizes balanced meals. The difference may be invisible short-term but substantial long-term. Cognitive aging speed diverges significantly. Brain decline rarely occurs suddenly. It reflects accumulated cellular stress. Prevention is invisible, while consequences are noticeable. For this reason, dietary habits matter years before symptoms appear. Mental sharpness is not determined solely by genetics or puzzles, but also by metabolic stability. Stable fuel supports consistent thinking. Unstable fuel forces the brain into survival mode repeatedly. Every meal sends signals to your brain. Some signals promote inflammation and fatigue. Others promote clarity and resilience. Over time, these signals shape how your mind functions. Reducing excessive sugar intake does not guarantee perfect memory, but it reduces a major source of neurological stress. Protecting circulation, lowering inflammation, and stabilizing energy supply allow the brain to maintain performance longer. Your brain continuously adapts to the environment you provide. Feed it stability and it remains efficient. Overload it repeatedly and efficiency declines. The future state of your memory is being influenced quietly each day. The important question is not whether sugar affects the brain. It does, but how often you expose your brain to unstable fuel. Because long before noticeable memory problems appear, small metabolic stresses may already be shaping how your brain ages. And the earlier you change the pattern, the more protection you give your future self.